Good morning, student of class 8. Let's start our chapter pressure. As I already given you the concept about the pressure, and we have come to know that pressure is the force per unit area. This means that the pressure a solid object exert on another solid surface is its weight in newtons divided by its area in square meter. So pressure means force divided area. Pressure denoted by P, force denoted by F, area denoted by A. So you can say P is equal to F. And pressure always we measure by the unit we called Pascal, or we can say Newton per meter square. 1 Pascal is equal to 1 Newton per meter square. Today we are going to know pressure due to solids. Let's take an example. If a man wearing a flat-soled shoe steps on the foot of another person feel pain, what would happen if a lady wearing a pointed heel shoe steps on that person's foot? He would feel more pain, even if both the man wearing the flat-soled shoe and the lady wearing the pointed heel shoe. Weight is the same. This is because in second case you will get more pain because the pointed heel shoes wearing by the lady applies the force equal to the person's weight over a small area, because in a heel shoe the surface area is very less, so the whole mass or weight of person exert from this small area. Thereby increasing the pressure applied, whereas the flat-soled shoe applies the same force but over the large area. So therefore pressure reduces. So you can say when a solid object is placed on a surface, the weight of the object applies a pressure on that surface, and the pressure depend on two quantity. One is weight of the object and also the surface area of contact between the two surfaces. So since P is equal to F by A, so P is directly proportional to force and P is inversely proportional to surface area. It means that if you increase force, then pressure also will increase. If you decrease force, then pressure also will decrease. But in case of surface area and pressure, they are varies inversely. So if you increase the surface area, then it will reduce the pressure, and if you reduce the pressure, then increase the surface area. For example, in this example, when the lady shoe which has heel, so this is a pointed sharp, so as a result, since the surface area is very less, so all the force exert from the small surface area, as a result pressure increases. But when the man wear the flat shoe sole, in that case the surface area is more, though weight is same, but because of the surface area more, so pressure decreases because pressure distributed over the surface area. Now let's discuss an activity to demonstrate pressure variation due to the force and area. Just now I told that pressure is depend on two things. One is force, or another one is area. This force sometimes we can say weight also, because force unit is Newton and weight also we can say is a force. So now let's discuss how pressure varies due to force and area. To perform this activity, we require to manage some material, number 1, 2 or 3 bricks and a plastic tray filled with wet sand. Procedure. First step. Variation of pressure with force on the wet sand. Keep a brick gently without applying any force on the brick. After it has made an impression, gently leave the brick and measure the depth of the impression. Next, in another part of the tray, place 2 bricks as you see in the picture, one on the top of other on the wet sand. After bricks have made the impression, remove them and measure the depth of the impression made. You can do this with more bricks placed on of one another. We can observe that the more the number of bricks, the deeper the impression made on the sand, because its weight is increasing. This implies that the more the weight added for same area, the greater is the pressure applied. So we can further investigate with different orientation of bricks. So in this student, you have understand here, whenever we have placed one brick, then the impression made very less because the weight is very less for one brick. But whenever we place 3 or 4 bricks, then the impression made on the sand is very deep because here weight increases. So we can say whenever force increases, the pressure also increases. As I told you that force and pressure are directly proportional. But pressure not only depend on the force, it is depend on the surface area also. It is depend on surface area inversely. So let's check this one. On the wet sand, gently keep a brick with largest area. So you can see the brick is in horizontal position on the sand without applying any force on the brick. After it, you can see an impression will create on the sand, and now measure this depth of the impression. Now repeat this experiment by placing this brick on the sides by vertically placing on the sand. Now again you measure the depth of the impression. You can see whenever we have placed the brick in vertical position, then the impression made is very depth. We can observe from here that for the same brick, that is the same weight, placing it on different side with different areas creates impression of different depth. That means whenever we place the brick in horizontal way, then you can see the surface area is more, which is contact with the sand. But whenever we place the brick in a vertical way, then you can see the surface area is very less of the brick which is contact with the sand. So as I told, that surface area decreasing, then the pressure increasing. So you can see the second brick which is placed in vertical way, that will create more deeper impression, means pressure increases because surface area decreases. So from there we can say pressure is depend on force and surface area. Pressure is directly depend on Force and pressure is indirectly depend on or inversely depend on surface area.